Hello, my friends. Today we're gonna continue our video series for ladder logic programming. Last time we was talking about the sequencer output control, in which we can control multiple output in sequence. Like as I have said last time, if we have 4 output or 4 motors, and we want to run motor A, then motor B, then motor C, then D, and then starting again A, B, C, D. So this is the sequencer output. So instead of writing a very lengthy program and many line of code to control some outputs in sequence, we can use only one instruction, as I told you. Here you can see the example we have made last time, but this example belongs to Alan Bradley. So there is a SQ0 instruction, the amazing instruction by which you can perform the sequencer output for the ladder logic program, your program. But unfortunately, in some programming language, you will not find one instruction that helps you to make the sequencer output control. So do you think we will go without it, or we will say, oh, there is no way to make a sequencer output? No, as a programmer, you should keep thinking and keep brainstorming with yourself and your pen and paper until you find a solution for every single problem. So here if you can see here in the sequencer, so what we have in a sequencer, to thinking like we have the output, a series of output. So we have here a series of output, like for example 4 output. Okay, this is 1, 2, 3, and 4, and every single time you want to run this, and then you move to this, and then move to this, and then move to this. So this is the point. So if I move from left to right like this until reach to the Q0.0, Q0.3, and then return back to 0, 0, and 0, 1, 0, 2, 0, 3, and so on. So you can see here a rotating shift to the right, and this instruction is the key for you to perform the rotating the sequencer output in Siemens by using the rotating shift. So the normal logic or thinking will takes you to thinking like I will start with a pattern, and that pattern might be like 1, 0, 0, 0, and let me make this bigger to let you understand. And then by moving this to the output, so this one will be on. Okay, so this one will be on, as you can see, but the other are 0. And the next time when you make a rotating shift, this one will become 0, 1, 0, 0. Let it be in same color like this, and in this way it will be like this one will be shifted. So I will have something like this. Okay, but the second one will be on, so this one will become here, and so on. When this one shifted another bit, like it will be 0, 0, 1, 0, and then it will be 0, 0, 0, 1. So the output will be also shifted one more, like this one will become here, and at the end this one, okay, will be like 0, 0, 0, 1, and after completing the next time it will be, this one will become here to return to the first state. And you can see, so how we implement this. So for saving the time of our session, So I already implemented the program. So let's go to the simulator and the program and see how I implement this thing. But let's first, before running the program, to understand, to make things clear and describe what I have done to make this shift. So I started with a data block, and this data block, for sure, I will start with one, and then I make a rotate shift by one position, and then move this thing to the output buffer, which is QW00. This is the word of the first output of your first track, and then I used here a timer to show you like a sequencer will working every single second. It will run one another output. So here what I've done is like I just move the data back to the data block, okay, after this shift, and then I run the timer, and after run the timer, what happens is I make another shift, and by make this other shift I run the timer, and after one other second I will update the data all the time, update the data, shift the data and move to the output, update the data by the output, and so on. It's very easy and very smart. So let's see the what happened here. So once I start from beginning, so you can see here the data. I will start with one, and this thing like this data block is the data I used to make this is the my output, and in the same time I will see the data block by which I used here. So I make this also displayed in binary to show all the the data. So I need to just changing this format, display format, to be binary. So you can see here I started with zero, with one here. So this output Q0.0 will be on, and all other will be off. So let me see this screen. I'm sorry, let me see this screen and split this screen together to see my output. So this is one screen and this is another screen here. Okay, you can see guys here the when I starting my program here to enable the sequencer. So what happened here, you can see how the data is shifted. Yes, so this output, the next output, the next output, the next output, the next output, until reaching to the last output, and then the first output will begin, and so on. This is a sequencer. I know it's amazing. I know it's very smart, and I know you're happy by see this with me. But I will be also happy if you understand everything I have described in this session, and I will be more happy if you just pause the video from time to time, and you open your simulator as I showed you in the first beginning of our sessions in this video tutorial. So open your simulator now and implement this 3 line of code and enjoy your output sequenced as you can see here, because this is not a project, a complete project, but this is a very important task that helps you to control the sequence of a multiple output to run in sequence, as you can see, by a very simple technique like this. And instead of just like writing a bunch of lines of code to make each one to be on, and then the next one, and set off the previous one, so it is complicated and the unreadable code, and I think it's bad in maintenance. But when you make it like this, it will be very easy to read, very easy to follow and maintain. So this is the way you program your code, and I hope you enjoyed this session, and let's meet in the next session to make sure everything working correct and fine. So here let me resume what I have done in this session. So I started my session to showing you the sequencer output, which is the continuation of the last session, in which we have done the sequencer output in Allen Bradley. And here we because we don't have the one instruction to make the sequencer output, so we implemented it by using the rotating right shift. So again, we have used this instruction by shifting the initial data 1 bit each time, and then updating the data by, after moving into the output, we updating the data again and shift again, and so on, shifting, rotating, and once we reach to the last bit of the output, we continue rotating shift to the right to enable the first and the second, and so on. So again, this is a sequencer, and I showed you also here the how to track this data by creating a data table here to showing the data block I used to be as a mask to control your output in sequence, and also to show the output bit by bit, which is implemented. So thank you very much, and I hope you enjoyed my session, our session, and let's meet very soon in another session. Thank you very much, and have a good day. Bye bye.